I'm going to talk a little bit about a project that is about, I think, in its decade anniversary here at UMM, here at DEI, and that's this surf clam called Mactromeris polynyma. You might ask, well, you know, surf clams and Mactromeris. We have a surf clam. It's called the Atlantic surf clam. Its genus and species is Spizula solidissima. And that's an animal also called the hen clam that does grow around here, but Mactromeris is a deep water species, and we wonder why we're actually working on it. So this is what the adults look like. This adult is about 4.5 inches, and it was dredged from an area in the upper St. Lawrence River, about 5 hours north of Quebec. And it is valued not for its size and not for most of its meat, but for the foot that you see here. There are very few clams that have any kind of coloration, and this one does. But not only is it colored like this, it's a circumboreal species. You can find it in the Gulf of Maine. It's only commercial in the maritime provinces, where it's about $100 million fishery. And it's dredged at depths between 100 to 200 feet. So it's a deep bottom dweller. And here are the factory ships that are collecting and processing them at sea. These feet are quick frozen. You can find them a lot in Thai and Asian restaurants called hokagai. They're very beautiful, and they're wonderful to eat. But it turns out that the animal itself, not just the foot, but the whole animal is really good and edible. And so this is a species that has never really been cultured, and it turns out that we can grow it in our mudflats. We learned that because of a paper that was published in the early 1970s from Alaska, where intertidal populations of this species were collected in bottom cores. So we know that it can grow in the intertidal, at least in Alaska. And so we started this project in 2011, and we're still working on things today. When you steam it, this is what it looks like at a size of about an inch. And what our goal is to create an animal that's about 2 inches, or maybe 1.5 inches to 2 inches. And then work with folks, clammers, and anyone else that's interested to sell this. Now, we know that it is definitely a prized possession, and that individuals will cost quite a bit. In fact, it'd probably be worth more than quahogs and oysters when we finish doing this. But it's visually stimulating. I mean, how many species of clams do you know that when you steam them, they turn this beautiful shade of orange? So our goal is to culture through spawning, broodstock conditioning and spawning, larval rearing, to create an organism that ultimately is large enough to plant in mudflats, so that we can grow it to a size that will be commercially viable. If you want to deep fat fry it, that's what it looks like in canola oil at 325 for about 1.5 minutes. It's just a beautiful thing. So this is the area, the upper St. Lawrence River, Natashquan in Quebec. That's about 5 hours travel from Quebec. And we were granted permission by the DMR back in 2011 to bring animals from that area to DEI after they had been sampled for different pathogens, and they passed. So that's how we were able to get our broodstock. And we held these broodstock. We didn't really know much about how to hold them, and we lost an awful lot early, but we were able to spawn them eventually and to produce larvae that grow and develop like most bivalve larvae. I could tell you that that's a Mactromeris, but I could also tell you that that's a soft shell clam or a mussel. They all look pretty much the same until they're about a week and a half to 2 weeks old, and then they start taking on different sizes and different shapes for the different species. This is what juveniles look like, and what's interesting is that unlike softshell clams that have a long siphon, these do too, but softshell clams burrow as they get deeper, get older and get larger. They burrow deeper and deeper into the sediments, and that's what protects them from their predators. And this one is a very interesting species because it doesn't burrow very deeply, even though it has a long siphon. And so it's very susceptible to predators. And that's key for how we have had to move ahead with our field research, which is what this talk is really going to focus on. So we started by using the same techniques that we used for raising softshell clams, which was grow them out, grow them to a size where they'll stay on window screening, put them in trays, and float them in Mudhole Cove. And when you do that, you end up with animals that are misshapen. They don't grow very well. It's difficult to see, but not only are they misshapen, but the valves can't close. So you can look right in and see their foot and their meat, and they're alive. You can see how healthy they are. They've got nice deep guts, but their shape is just all wrong. And what we inferred from doing several different experiments with sediment that we put into these containers and then put these containers into what some of you know as overwintering containers out here, and then put these in the ocean, was that they don't do very well when they're moved around. And so if they're in a floating tray and there's a current or there's a storm or there's any kind of water motion, they deform. But if they're in sediment or they're in a place where they're not moving very much, they do just fine. So we learned how to nursery them to a size of about 1/4 inch or 6 millimeters to 10 millimeters. And this is the sizes that we've been using in most of our field experiments. They're animals that are 1/4 to 1/2 inch in size. So we started back in 2011 by looking at a couple of different sites where I had done experiments with softshell clams down in Cutler. Here's one where we planted them the day after the 4th of July in 2011. We let them go until November, and we saw that, yep, they grow. They grow in the intertidal, and that is pretty good proof that this is a species that we can at least work with. So then we began doing some small scale studies looking at predation to see what we would need to do to protect these animals, if we needed to at all, from predators. So we used plant pots that we pushed into the mud, and we planted different densities of clams in open containers, as well as those that are somewhat protected from green crabs. I say somewhat because the meshes on here are much larger than a green crab is when it settles, which is only 1 millimeter in size. So green crabs could actually get in here and grow, and we just hoped that the experiment was over before too much of that happened. The other thing that we've done is to take a look at the effects of density. So we've placed 1, 3, 6, 12, or 24 clams in some pots, and the same amount in protected and unprotected pots. And we've placed these out. This is a site at Cutler at different tidal heights. And what we found is that the clams don't grow very fast, and they don't do very well in the upper part of the intertidal. So our studies are concentrated from the lower mid into the extreme low intertidal. In fact, some of the sites that we are using, we can only get there on tides that there's a full moon or a new moon. Those are the spring tides, where if you look at a tide chart, it says minus 1.2 or minus 0.7, as opposed to a plus 1.7 or a plus 0.3. So we're using negative tides that really are below the mean low. And they grow. They grow, and when they do grow, they're absolutely beautiful. However, it turns out that predation is keen. And here's a shot that looks at a study that we did at Cutler. and a study that we did at Beal's Island from the 6th of April to the 18th of October 2012, where we had animals in open containers. And you can see that survival was less than 5% in cutler, and it was 0% in Beal's. And even in netted containers, we were only able to get about 65% survival, which isn't that bad. But in Beal's, we were only able to get 30% survival. And when we looked at the growth rates, they averaged about 8 millimeters when we put them in, and they averaged about 14 when we took them out. But you can see how variable growth rates are. And in cutler, the same size distribution going in, and they grew slightly larger, but not significantly so. And what we found out was that the problem was not with, the design, the problem was with material. And I'd never seen this before with soft-shell clams that I had spent over 25 years doing very similar experiments with. The netting was destroyed, and the animals inside were just fragments of shell. And I thought that was very, very, very strange. So we, at the same time, were trying to see what kind of techniques that we needed to use to grow massive amounts of these animals. So we used the techniques that work with soft-shell clams. We were out on mudflats. There's Bennett back in 2013 and a former employee, Cody. And what we've done is we've seeded this area with small surf clams, and we're protecting it with nets that we put in very soft sediments, and then work our way around the periphery of the nets with our feet, pushing the edge of the nets down about a foot so that they're protected from crabs and other organisms that could actually burrow underneath the nets. The nets are also, once they're anchored, we use toggles or styrofoam floats under the nets that bring that net up, they kind of balloon when the tide comes in over, so that the nets don't interact with the siphons that are sticking up out of the mud. But what we found also with the large nets is what we found with the small nets, and that was that something was really keen on getting to those surf clams and destroyed our netting. So we said, okay, fine. We'll do something that they do out on the West Coast with gooey ducks, and that is to use PVC pipes. And what we did was we hot glued some very heavy duty mesh to these pipes and planted soft shell clams in some and surf clams in others. And then we planted soft shell clams and surf clams together in other pipes. And we did this a few years ago. This was a student project during the summer. There were 2 time periods, one from the middle of June to the end of October, and one from the day before the 4th of July to the 20th of October. So we had 2 different times. And this was done in the very soft intertidal of Mudhole Cove. And there's our setup. And we would then count out the number of clams and then push the pipes over them so that we would leave the pipes about an inch or so above the sediment surface. And there we have it. And here's our results with Maya. So it really didn't make any difference if they were with Mactromeris, but those in the first instance didn't survive as well with Mactromeris. You'll see why in a moment. But the second time, there wasn't much difference between the two. There was an average survival of 80%, which isn't that bad. Now, with Mactromeris, however, there was a difference in survival. The average was about 42% for the first time period, and it was about 25% for the second time period. And Mactromeris didn't survive as well with Maya in the first time period, but it did survive better in the second. And I have no idea why. However, the answer to why generally there was less survival of Mactromeris was because of what happened to the pipes. So some of them look like this. There was no damage. They looked exactly the same the day we hauled them out. Some of them had what we call minor damage. just a few little incidents of something wanting to attack. Then we had others that had a little bit more damage, which I call major 1. And then we had pots or pipes that look like that. Now, this is pretty rugged stuff. It would be difficult for you to take your fingernails and to do the same sort of thing with, or even your teeth. So something is very interested in surf clams. This is Bennett holding up a pristine container versus one that's really been chewed up. So once again, we found out that predators are very important in this system. This is just the results of what happened to the netting that was on top of those pipes, and you can see that there's not a lot of major damage to the ones that contain soft shell clams, but that 100% were either major damage 1 or major damage 2 in that second time period. So we also did experiments that suggested that, well, maybe we need to get these animals a little bit further away from the predators. And so what we did was we designed experiments where we only filled up half the pot with sediment versus completely filled with sediment. And we used 2 different kinds of netting, 3.2 and 4.2. You're going to say, well, gee, there's not a lot of difference between those two, but there might have been. And then we added 12 Mactromeris juveniles to these plant pots. And there's 4 treatments. And then we had another 4 treatments, which was, well, we'll completely fill the pots, but we'll put some kind of a system in there so that the netting is above the clams, so that, again, they don't interact with the material. And we used hardware cloth also on some large-scale 6-inch diameter pipes, because we thought maybe the hardware cloth would hold up better than the plastic. So we designed an experiment that had 2, 4, 6, 8, 10 different treatments times 2 replicates in blocks of 4. And we set this experiment up at 10 different flats from Kittery, Maine to Cutler in the fall of 2016. And I'll just give you the results from a couple. So pots were either flush, or those pipes were either flush or what we call lifted, and the pots were flush, flush with a dowel, and then half filled. And what you can see from this generally is that if the treatment allowed for the clams to be away from the top of the screen or the top of the mesh, that we got much better survival than they did if the pipes were flush or the pots were flush. And so that tells us that we need to be able to somehow create, on a large enough scale, a system of keeping the netting always away from the animals. This was in Freeport. I show you the Freeport results because that's where clams survive the best between September and the following April. So this was an over the winter experiment. And they also grew the best, the fastest. So for example, these went in at a little bit greater than 1/4 of an inch, and they came out at a little bit more than an inch. So they grew about 3/4 of an inch on average, which is pretty good growth. Now, let's see, I'll keep going. So this was the kind of unit that we used with the using dowels and keeping the netting lifted off. That was an important find. It didn't work all the time, but in general, if we pooled all the data from all 10 sites, it was an important find. This was some of the animals that grew, and I don't know if anyone has talked to you about something called the hatchery mark. Those are 2 soft shell clams that happen to be in this particular thing by accident. But regardless of the species that we grow here that are clams, whether they are quahogs or whether they're soft shell clams or whether they're these surf clams, that they lay down a disturbance line in their shell that is equal to the size that they were when they were put in the mud. And what this allows us to do is to take those animals and get a growth rate from them. So there's the hatchery mark. So we take our calipers and measure the size of the clam that it was in September, and then this is how much it grew until the following April. And that gives us an individual growth rate on an animal that we didn't have to mark. It marked itself. And so all the growth data is similar. These are the results from Mudhole Cove, one of the 10 study sites. And you can see, again, in general, if they're, lifted or a little bit lifted up by the dowel, that we got better survival, although the survival wasn't nearly what we found in the Freeport area. And neither was growth. Remember, the growth went up to 26.5 in Freeport. It only went to 14.2 in Beals, starting at the same size. So one of the things that we found was even in the hardware cloth treatment that we got damage from predators. And then in 2017, the nightmare began. And I see Kyle and Ben are here. So we decided that, let's try a different tack. So what we did was we built some pet screen bags and put Mactromeris in those bags, and then placed these bags into these oyster containers that we placed out on mud flats that were anchored at both ends. And this was a study that we set up at 5 different places in both Washington and Hancock County. And this is a site over in Stew Bend where we got kicked out on the left, and in Lubec where we also got kicked out. But it was okay because the results that you can see, that's Kyle's hand, and that's the results. And if you can't see that very well, this is the result of a bag. And if you look really closely, you can see 1, 2, 3. Do I hear 4? Maybe 4. But the Mactromeris didn't grow very well. And furthermore, they didn't survive at all. And that was a hard pill to swallow. So I said, okay, guys, I got one more idea. And if this one doesn't work, we're done. So, going all the way back to the dowels and lifting the pipes that worked well, we built boxes. And these were 6-inch deep boxes that had pet screen bottoms. And we put sand that we bought from the local hardware store in them, because what we didn't want to do was to take the mud and put it in the box, because the mud might have small green crabs in it, or it might have Cerebratulus lacteus. Does anyone know what that is? It is. It's a nemertine worm that does a great job on soft shell clams and probably Mactromeris as well. It everts its proboscis into the animal through the pedal opening or through the siphon and injects a toxin that then begins to dissolve the tissue, and then it eats the tissue with its mouth and leaves a very intact, undamaged clam. So we didn't want any of that to happen, at least initially. So the boxes were built, they were put on top of the mud. And then we planted Mactromeris at various densities in these boxes. And we placed the boxes at 2 different sites. Boxes had either 50, 100, or 200 animals. And we placed them at the 2 sites that we had historic data about growth and survival of these surf clams. Again, Mudhole Cove and Duck Brook in Cutler. This experiment lasted from the middle of April to the end of September, early October in 2019. And every time I look at the results from this, I know that some of you will say, oh, someone fudged the data. And you'll think that when you see what happened. The tops, it turns out, are the key ingredient in all of this. And what we did on this one was to build a very flimsy top that we just simply put 2 layers of 4.2 millimeter mesh in between some lath strapping. And then we nailed these tops to the top of the box. So we had 5 replicates of each treatment at each site for a total of 30 boxes, 15 at each site. And when Ben helped me on the 29th of September to sieve these, the first thing I did when I opened up the box was to say, I've never seen this before. And that was, I was expecting death and destruction, because that's all we'd ever seen. I didn't see any black spots on the mud where the meat had rotted and there was anoxia around the animal. It was nice. Look at these boxes and look at the siphons sticking up. This is what is attracting the predators. All of these siphons. That's how they do it. And when we took all the mud and the sand, because these boxes receive mud just because it's in the water column and it settles out. So it's mud over sand. When we took all the sediment out and started to sieve, a funny thing happened. We got a lot of clams, a lot of surf clams back. I mean, a lot. Look at that. That's one that had 200 in it. And guess what? There's 200 clams there. And they're alive. And here are the survival data. 98% of the ones with 50 in them survived, 98% of the ones with 100 in them survived, and 99% of the 200 survived. Here's the real data. Here are the actual numbers of live clams from each one of those boxes. And there were 2 200s and 2 199s alive in those boxes in Beal's Island, where we know that predation is intense from the past experiments that we had done. I've never seen data like that, ever, and probably won't. I haven't seen it since. And so there was no effect of density on survival, nor was there an effect of density on growth. The average was between 17 millimeters and 18.5 millimeters, and that was really interesting because we thought, gee, with 200 animals in there, there's probably going to be a density effect, and we didn't see it. They grew from about 10 millimeters to about 28 millimeters in that time. What we would like to have is an animal that's in the 45 to 50 millimeter size range, which would likely take at least another 1.5 years, but we stopped the experiment here just to see what was going on. Now, in Cutler, we didn't see quite the same results. 60% survived in the 50s, and about 60% survived in the 100s, and much, much lower survived in the 40s. And then we have these error bars. And the error bars are a measure of variability. And there's why the error bars are so tall. Because, oh my gosh, some of the boxes had exactly the same number that we put in, the same kind of result that we saw at Mudhole Cove. But then other boxes had nothing. Here's a box that had 199 in it, and 2 other boxes that had 0 and 2. There was one of the 200s that had 194, and all the rest had very much fewer. So what the hell happened? Well, if we take those numbers where, things look like Mudhole Cove, and we look at those, we see that, something unique happened. And what happened was, I don't know if you can see it in this shot, but there's a huge hole in the netting of this top. And obviously, there's a huge hole in the netting of that top. And what we think happened was that seagulls were working in concert with crabs. And they were able to somehow get into these boxes. Because when we sieved those boxes, there's a green crab that's the size of your palm. And there's another one, and another one, and another one, and another one in this 200 that had 1 survival. So the mesh on top of those 15 boxes, the ones that remained pristine during the experiment, that's what the clams look like. No problem. They look just like Mudhole Cove. And if we just take those 1, 2, 3, 4, 5, 6 boxes out of 9 that had pristine tops, the data is no different than Mudhole Cove. survival was 99.3%, where the tops remained intact. So the key then is to create a top that is a fortress. And rather than use just the regular old flexible netting, what we've gone to now is rigid, that's protected by lobster trap wire. And so we're using 3 different sets of nets. We're using the flexible that's closest to the clams. Then we have this box that's either an inch top or 2-inch thick top. The top of the container is the lobster trap wire, and that's over this heavy-duty polyethylene fabric or netting. And then what we've done then is to go back to Mudhole Cove in our current project, where we've put out boxes that are either 1x2s like we used in 2019, or 2x2s. And these are exactly the same. We put in sand, and we've put in either 50, 200, or 100 in those smaller boxes, or 100, 200, or 400, so that the densities are the same in the larger boxes. So we are looking at box size, we're looking at stocking density, and then what we've done is we've varied the size of the top. Either have 2-inch thick tops or 1-inch thick tops. And this experiment was put out in 2020, and it turned out that box size didn't make a difference, and stocking density didn't make a difference, and top thickness didn't make a difference. And the survival rate was around 70%, because we did have green crabs settle in some of the boxes and grow. They didn't rip or destroy any of the tops, but green crabs still got in naturally. This is how we set it up with Jeff Robinson and Kyle and Bennett. And were you there at the beginning of this one? I'm not sure. Yeah, maybe. I think you were. Well, when did you start? When did you start working?
October
Of
2019.
Then you were here. Yes, you were out there with us then. There's a 2x2 foot box that either got 100, 200, or 400. And then this is simply putting them out. And that's what the matrix looked like. So in summary, these animals can be cultured and grown in the lower intertidal. The problem is that they've got long siphons and they don't burrow very deeply at all. And that's an unusual combination that creates a lot of challenges. And crustaceans, probably working, as I said, in concert with gulls, were the biggest nemesis to successful production using the typical kinds of materials that work with softshell clam, cultured softshell clam juveniles. We don't know yet whether or not this is going to emerge as a new culture candidate, because it depends on that word right there, the costs to deter predators. In terms of growth rates, it doesn't look like they will grow very well in Freeport for a long term, because the water temperatures from June to September are beyond the thermal limits for these animals. And so they'll do just fine between October and April, but they don't do very well between April and October. So there it is. Thank you very much.